I think we can get started. If there are more people joining, we can certainly catch up quickly. But yeah, let's get the party started. So yeah, I'm really excited to be here today. As you can see, today's webinar is focused on building an industrial data pipeline using AI and MCP servers. So here is today's agenda. First of all, I just want to introduce myself and what I mean by an industrial data pipeline, and then also introduce Quix a little bit, the company that I'm representing, and also the concept behind MCP servers and why you would want to use them in industrial data pipelines and the use case for AI. And after that, we'll go through the demo. So I will demonstrate two use cases. So the first one will be using AI and MCP servers to scaffold a pipeline, the structure of the pipeline in the Quix platform. And then I will use AI to code an aggregation app using the Quix Python library. Note that I'm using it as a coding assistant rather than using AI to actually analyze data. We'll be using just plain Python code to analyze data, but AI will help us create the code using the specialist Quix library. And then I'll open it up to questions in the last 15 minutes. Okay, so let's get started. So first of all, my name is Mona Carter. I'm a developer educator here at Quix. I'm originally from New Zealand, but I'm actually based in Berlin right now. And so my background is as a technical writer and also a product manager, but I've also dabbled in computational linguistics, natural language processing. I've also spent a lot of time exploring media art, creative coding, physical computing, you name it. Yeah, and so my current area of interest lies at the creative applications of large language models using AI for image and video generation and generative media art. Just to give you a taste, this slide shows just one of my personal explorations using AI for creative purposes, generating narratives from climate data and what have you. But anyway, enough of that whimsical stuff. Let's first take a look at what we're going to build or the concept of what we're going to build. So what exactly do I mean by industrial data pipeline? So here I'm using a very broad liberal definition of industrial. So I'm talking about data processing pipelines that are designed to derive insights about any kind of industrial system. And with industrial systems, I'm going with this very liberal definition that includes the things you'd expect, like factories and manufacturing plants, but also energy providers and things like that, water treatment facilities, and so on. Basically, any large-scale physical system where you want to use sensors and data to improve how those systems operate. And I'll talk more about the Quix platform in a second, but essentially the platform addresses two broad use cases. So on the left here, we have industrial operations, and that's about getting data out of OT systems, think factories, IoT devices, connected vehicles, and piping that data into IT systems with the goal of real-time monitoring, predictive maintenance, alert detection, and so on. And so you can see data flowing from remote locations, perhaps via telegraph through MQTT, HiveMQ, and then into Quix, and then afterwards into a batch system such as InfluxDB for querying offline. And then on the right, we have our main use case, which is industrial R&D. So here, data might be coming from test systems or simulations, perhaps using software like MATLAB or Simulink. And the focus here is often running multiple tests, comparing data between those tests, and iteratively improving models. So for example, simulating a battery and enriching its output with the test configuration metadata, using that data to refine the control signals in an adaptive control process. And a core part of this process is aligning raw data with the simulation configurations and the test configurations so that you know what settings produced what outcome. However, we won't be building anything so complicated in this demo. So I'm going to stick with the first use case because it allows us to create something a little bit simpler, but still representative of an industrial monitoring pipeline. So here we're going to have data coming from a simulated solar farm, and we'll have an HTTP API producing weather data, and we're going to enrich that raw MQTT data with the weather conditions. And then we're going to read from that processing step and then have dangerous condition detection in case the weather is too stormy or what have you. And we're also going to get some stats aggregated by location so that we can get like a high level dashboard of what location is producing what power. We won't have time to code all of these steps with our AI powered code assistant. So we're going to just focus on one, which is the aggregation by location. And this is the one we'll use AI to help us with. But before we get into that, let's just quickly go into more detail about Quix. So Quix has its roots in a very demanding environment, which is Formula One racing. And it was originally built and used at McLaren Applied, where the founding engineers needed to monitor incredibly high volumes of sensor data coming from Formula One cars in real time. And you can see the stats there on the screen. So they needed a reliable data infrastructure to process this data instantly and provide feedback to drivers and to the pit wall. And so they realized this powerful infrastructure could be generalized. And so Quix was developed as a cloud native platform for processing telemetry data from any kind of system. And a core part of the Quix tech stack is the Quix Streams Python library. And so this is a Python library that was designed specifically for stream processing and to interact with Apache Kafka or other compatible message brokers like Redpanda. And it's used to perform complex data processing operations in real time. And so the Quix team, by the way, chose Python because we know that data scientists and mechanical engineers prefer Python quite often for its ease of use, especially if you're not a full-time programmer. If you're a casual programmer like me, and I think maybe mechanical engineers or research scientists are the same way. And so you need to program to do certain tasks, but software engineering is not your main specialty. And especially with the rise of vibe coding, I think this is becoming more common, the casual programmer. So anyway, the Quix Streams library aims to make that journey as smooth as possible. Whoops. So the Quix Streams is based around the concept of a streaming data frame. And so many data scientists are familiar with pandas data frames for working with static data. And so Quix Streams basically takes that paradigm and applies it to streaming data or data in motion. And okay, so what kind of companies use Quix? So as you can see, we have a variety of different use cases. We have Juniz, who's using Quix to monitor battery performance, to monitor their energy grids and see if any batteries need replacing. And then we have another manufacturing company that produces heavy machinery, and they want to use Quix to monitor the machines on behalf of their customers. And then we have a CNC center that is also using Quix to analyze and optimize the production capacity of their CNC machines, again, using machine telemetry for data insights. And what's quite common use cases that they aggregate this data and simplify it and prepare it for ingestion into a database so that it's easier to run queries on it and to look at dashboards based on the aggregated data. So how do real industrial data pipelines look in Quix? So here's like a few screenshots. And you can see that it's quite complex. There are quite a few services connected that that ingest sensor data and telemetry at scale. But you can see how it's kind of handed incrementally in task-specific steps. And you could maybe compare roughly to these steps to cells in a Jupyter notebook, except these are Docker containers that run processing apps on a continuous feed of data rather than a static data set. Which leads me to this unusual slide here. So I wanted to find out a paradigm to explain batch versus streaming. I apologize for the kitsch oversimplification, but so this paradigm of batch processing is like the snake with the ice cube. You have to load a large data blob and do a one-off piece of computation. And you might see this typically when you load an enormous CSV or Parquet file into Jupyter Notebook, and you have to wait for the ages for that file to be loaded into memory and for it to be processed. Or maybe when you're doing an SQL query on a raw high-frequency data table where you might have a reading for every millisecond and you want to aggregate by machine or whatever, that there's a lot of data you have to crunch. And so, yeah, it's like the anaconda trying to swallow the giant ice cube. And there's a big spike in cluster usage, and you have to wait for the entire process to finish before you get any results. Whereas with incremental stream processing, you're slicing the data into record by record chunks, and then there's no spike because you're spreading out the computation over time. And so this is very crucial for speeding up any data-driven workflow where, such as monitoring or industrial R&D, where you've got huge volumes of high-frequency telemetry data, but it takes ages to process it in batch because you don't want to be waiting around for these big jobs to finish because it reduces your time to insight. So with that in mind, now that we understand industrial data pipelines, where do MCP servers fit in? Where does AI fit in? So just a brief intro to MCP servers. It's a protocol developed by Anthropic, the makers of Claude, and they were trying to make a standardized protocol for basically calling tools and functions, because every AI system or every AI client uses a slightly different system. So they wanted to be the HTTP of AI systems, as they say, or they also say USB port for AI systems, but I don't know. I'm not really a fan of USB ports myself, a bit frustrating to use. So let's stick with the HTTP metaphor. And anyway, the core idea is to make it easier for AI clients to use external tools. So yeah, and so if you want a more detailed primer on MCP, I really can recommend this video by Tim Berglund, who's a developer advocate evangelist for Confluent. And a lot of the content out there about MCP is from like AI influencers who are aimed at hobbyists or solopreneurs. But Tim does a great job of explaining MCP to people who work at larger enterprises or startups, and so who might have missed out on the earlier MCP hype. And so this really helps to understand the power of MCP protocol for businesses. And so how do you build an MCP server? So basically we took the REST API for our platform, and we took the Swagger documentation, and we basically ran it through Claude Code and we gave it the MCP documentation, said, please create an MCP server out of the Swagger documentation. So it's basically got a lot of the same content, the documentation of how to use the API, but it's just in a different format according to the protocol that the MCP clients expect. And so the reason why we needed our own MCP servers is because Quix is a specialist tool, and although generalized models have some knowledge about what Quix does, it's much more useful to give it that more specialized knowledge through tools like RunNLM or even the documentation. And of course, we need an MCP server for the AI client to actually interact with our platform. So, and one thing to note is that Quix is very tightly integrated with GitHub. So it's a little bit like a regular build system. You commit something to GitHub, and then the applications get built and deployed to Docker containers. So Quix works in a similar way. Yeah, so those are the servers we're going to use. And I mentioned RunNLM in the previous picture. So as I mentioned, an AI client needs to get knowledge about a particular specialist tool. So there's two ways of doing that. You can give it the documentation and you can allow it to search the documentation. So we're using a tool called Context 7, which allows the client to actually run keyword searches across the documentation, and they've ingested it into a vector database. It's made by Upstash, and so you can get documentation results that way. But we've also got an AI agent that is actually being trained on our code and our documentation. And that is more sophisticated because you can ask it a natural language question and it can answer more accurately based on what it's ingested from our specialist knowledge repositories. And so that's very useful for the AI to be able to ask another specialist AI for help when it runs into trouble. And with regards to configuring AI agents, for the time being, you still have to configure them mostly in JSON configuration files. So we connect to remote MCP servers using the SSE protocols. So you specify the protocol type and then you give it a URL. But I'm also using a local node library to start an MCP server that uses the Quix docs. And by the way, when you change the configuration in Claude Desktop, which is the client that I'm going to be using, you have to remember to quit it and then restart it because it's something that trips a lot of people up. And here's just for comparison an example of MCP configuration in Cursor. So Cursor is trying to have more plug and play MCP servers, but you still need to edit JSON if you want to add something custom. Yeah, and this is just how you confirm that your tools are working in the various clients. So Claude Desktop lets you list the tools, and also Claude Code lets you list the MCP servers that you have available. All right, so time to get into the practical part. But first, I just want to say, expect the unexpected. This is AI. Every time I try this, it works out slightly differently. So, it's very terrifying doing this live because, things can always go wrong. But this is just a warning. It's not like running deterministic code. You can always get a different result. So anyway, with that said, let me go into the client. And so just to reiterate, I'm going to use a visual prompt to actually scaffold the project in the Quix API. So I showed this diagram at the beginning of the presentation, but it's a little bit more detailed here. I've added these gray boxes, which are topics. And those are basically like tables in the database paradigm. So each process outputs data and it needs to put it somewhere for another step to go and pick up later on. But instead of being static data that's written to periodically in batches, it's just continuous. So that's basically the topic paradigm. Okay, so let me get into Claude. So this is Claude Desktop, and I've got a project here called Portal Management Agent, and I'm going to get it to do stuff in the Quix platform. So let me just show you, make that more easy to see. So this is the Quix platform. I've only got 2 utility services in here running. So what I'm going to do is try and build the pipeline that I did from the picture and get it to reproduce that. So let me just copy that image and paste it into the desktop. Actually, what I'll do is I'll restart it quickly because sometimes the connection can time out and just go to sleep. So let me just restart again to be sure. Okay, here we go. So let's go into our project, Portal Management Agent. And I've got the picture. And what I'm going to do is just copy a prompt that I prepared earlier and ask it to follow these instructions. So can you please look at the attached image and build the pipeline for me in Quix? Don't deploy anything yet, just build it and connect the applications and make sure that everything looks as I've specified. All right, so let's go. Now it's going to think about it for a while and check to see what tools it has available. And when it starts working, we should start to see things appearing here in the workspace. So what it's doing first is it's looking into our libraries repository. So we have code samples for every type of application. And I'll just show you that. And this is the repo, by the way, that it's based on. So for the Python section, we have destination, sources, and transformations. And in the sources, you can see there are lots of different templates that you can use for bringing in data from external sources. And here we have a much fewer templates for transformations because there are so many different types of transformation that you can do. But yeah, anyway, let's go back and you can see here that it started creating the topics that it needs. I'm just going to go back to the main workspace view. Okay. So that it knows that it needs to create topics, and it knows that it needs to connect everything together. So we can see here that something is being started. Okay, weather conditions. So while it's doing that, I just want to show you the system prompt. So each project in Claude lets you add a prompt, a master system prompt for that project. So I've given it some rules about how to use the API, and I've given it an extra context about how to use the tools. And I've also asked it to check its work and been very stern with it about not trying to get around API errors, and basically told it to make sure that if you get an API error, you stop. You don't try to get around it, which is what it will tend to do if you don't give it that instruction. So yeah, you can see there's quite detailed instructions for it to follow. And that is defined on the project level. So if I click on the project, you can define that in the project settings. And these prompts, by the way, are all stored in the Quix prompt repository. So I've just started this here, by the way. This is a Quix prompt library. So we've got prompts here for the Quix MCP portal user. Okay. Claude thinks that it's finished. So let's check its work. I would be surprised if it's perfect the first time around, but you never know. Oh, wow. Okay. So let's bring up our drawing here. Okay. So what have we got? We've got this. Okay. I'm having trouble with Zoom. Okay. So we've got these two going into here. Yep, that's correct. And we've got the weather conditions enrichment being done here. And then we've got it outputting to two processes and then syncing to Postgres. Yes, so everything has been done according to what I asked. So that is nice. I didn't have to give it any corrections, which is sometimes what happens. So like I said, I'm not going to try and code all of these. I mean, these are all just being created with boilerplate code, so we'd still need to go into each service and actually update the code and then deploy the application. But what I've got here is I've got another version of the pipeline, another environment where I've kind of built most of it so that the data is actually coming through. So for example, in the enriched data, we've got solar panel data coming in with the weather conditions annotated with it. So it's got the data it needs to do the downsampling. So yeah, let's now go into build this app. I'll just update the MCP server to work on a different workspace. I'm just going to change that to do because we're going to need that in a second. Okay, so let's open Claude Code. I'm using Claude Code instead of Claude Desktop because I want it to be able to actually just write code instead of calling APIs, making API calls. So let's list. So these folders all correspond to the applications that you see running in here, and this basically corresponds to this view, where we just list the applications. So I'm going to go into, it's actually called average panel values in this one. So I'm going to just go into there. Okay. And first, Claude needs a bunch of resources to follow the instructions reliably. So it needs the environments. I'm going to change the SDK token after this. It needs a system prompt. It needs I'm going to give it a README for the Quix streams documentation, just so it has some extra resources. And it needs the prompt for the actual task. So I'm just going to copy that, paste it into the folder where Claude is operating. Okay, so I think it's got everything it needs to proceed. So let's start Claude. Oops. Yes, trust the files in here. Good. All right, so the first thing I need to do, I just want to make sure it can see the system prompt. So I'm just going to paste this question here. Oh, one MCP server failed. What is that? Oh, that's just the Jupyter one. Okay, that's fine. Okay, so can you read Claude MD, the thing I just pasted in there, and indicate that you've understood all the instructions? Don't do anything in it. Do anything else, just indicate that you understand. Yes. Okay, it's reading. By the way, I'm using the most expensive API that Anthropic has available. I switched it to Opus. Supposedly better than this one here, which is Sonnet, which they just released. But yeah, let's see how good it really is. Seems to be thinking. Let's see. All right. I knew that something like this was going to happen. Sometimes it takes its sweet time. I'm going to check my firewall just to make sure. All right, so it's understood that, so it understands the rules. Okay, so we are going to then give it the task that it needs to do. So please read task.md and proceed accordingly. Good. Yeah. Okay, so it has read the instructions. I'm going to show you the instructions just so you understand what we've given it. So I find when prompting for a task, it helps to give an example of the output that you expect. So I've basically explained the kind of aggregation that I want and the kind of output that I want and the structure that I want, and then given it some instructions on the data and the keys that it needs to use. But I've also told it to just consume from the topic and figure out what the schema is. Okay, so I told it to create an environment so it doesn't install things in the main operating system. And I also want it to confirm every step so that we don't miss out on anything that it's done. So normally I would let it run a few steps automatically, but here we want to see what it's okay. So it wants to install. Yes, do that. And okay, so I also told it to read the existing main.py, which contains very basic boilerplate. So just the raw structure of what you need for pretty much any Quix application. So it is going to read that and understand how you define topics and how to use the streaming data frame concept. Okay, good. And this step is basically to ask the run an LM tool. As you remember, I said we have access to a tool that it uses to ask about the documentation. Quix docs. Here we go. So let's put that there. And so this is basically, it's just using this tool here. It's doing what a human would do, asking it a question about how to do something specific with the QuickStreams library. So it's answered via the API, and it's given our generalist agent a code example so that it knows what it's supposed to be doing. Okay, so this step is, I've told it, okay, you need to understand that the data that you're working with. So before you go and actually do the real stream processing, you need to consume from the topic and just like running an SQL query on the table and understand what data you have available. Okay, so it's created a test consumer. Okay, yes, go ahead. All right, wants to run it in the environment. Yes, go ahead. All right, it found out it was able to consume from the topic, and now it is going to actually do the main work, which is implement the aggregation. So it's consumed from the topic and understood what it's supposed to be doing. And oh yeah, it needs to edit the in file so that we have the actual topic names in there. And now let's go back to the task prompt. So yeah, it's done this task basically. I've added this extra reminder here to use stop conditions because when you're consuming from a topic, it's not like running an SQL query. It's just constantly listening. It doesn't stop. So you need to tell it, just return 100 rows or what have you, and then stop. Otherwise, it's quite often just running in the background, and you don't know if it's doing something or if it's just listening and waiting. So that's why I've added these stop conditions. And so now it has analyzed and inferred the schema. All right, so it's added some code. Let's see if it knows how to run it. Let's see if it can run successfully. Has it created a test file? No, it's updated main.py. Okay, good. So now it wants to ask more information about the grouping operation. Yeah, so it's asking a particular question about windowing, which is, this is basically the process that you would go through with a freelance web developer, for example. So I've given it a basic product specification of what I need it to do, but if a human had gotten the specification, there's a lot of unknowns that I might have forgot to tell them about. So there's idiosyncrasies to do with windowing in Quix that it's discovered on its own, and so it's asking the agent, okay, so what exactly? How do I get preserved fields in the result? And so run LLM has given it the stuff that it needs so that it's going to update its implementation. And yeah. Um, all right, let's see. Okay. It wants to clean up the test consumer file. I don't know why, but okay, fine, do that. Okay, go ahead, remove it. We don't need it. There was a temporary file anyway. And it, of course, knows that it's supposed to add a stop condition. Okay, so it's creating a test file before it updates main. Yes, go ahead. Okay, so we've got an error, which is not a surprise. It usually encounters a few errors before it actually solves the task, just like a human. Okay, yep, go ahead. Yes, go ahead. Ah, yes. And this is a consistent problem that a human would probably run into, maybe if I gave it to an external developer, and it runs into the same problem each time. I mean, I could just tell it not to use sets, but I want to simulate the condition of, like, being a complete newcomer to the Quix Streams library. Okay. It's running it again. So I don't know why yeah, okay, interesting. Editing main.py. Okay, so I think it's getting ready to actually get it ready to commit. Okay, so it ran, okay, it's being very, very thorough. It ran a aggregation process, which output the aggregations to a downstream topic. So we've got, it put some data in here. Whoops. But now it's creating a consumer to make sure that actually reading from, there's some data in there. So it's being very thorough. Okay, it's cleaning up the timestamps. That's nice of it too. It makes it easier to recognize in queries. So yeah, maybe I take it back. Maybe Opus is smarter than Sonnet when it comes to figuring out issues like this. Okay, good. So it's done its job. It it it's created the code. I could go and deploy it using the GitHub MCP and push it live, but I won't do that because I think we're running out of time. But if you want any further resources, I've also included some extra information in the slide deck, which I can just show you now. So I've included some registries for discovering MCP servers so that you can find some more on your own. There's like open source directories and also hosted MCP providers, so people that actually host MCP servers and charge you to basically host them for you, charge for access. They use authentication to access the MCP servers, so they're kind of more trustworthy maybe. And then there are also these repositories of different types of MCP servers. So there's some very useful ones like GitHub's official one, Jupyter, Docker, file system, and then the ones that we've created ourselves, and also ones for cloud CLIs like Azure, AWS, and Google Cloud. And then, of course, there are various tools for debugging MCP servers and turning your Swagger spec into an MCP server as well. And of course, a whole bunch of MCP compatible clients out there, from chat clients to Claude coding agents. I've indicated my favorites here, but yeah, there are plenty to choose from. A few of the cloud ones don't have MCP support yet, but I'm sure they will do soon. And of course, prompting resources and a directory of useful prompts, including our own prompt library that I showed before. And yeah, I mean, this is the extra slide. I wasn't going to show it, but I just wanted to show how much context the poor AI has to process, and you can understand why it gets confused. So we have the actual project artifacts, like the code files that you're sending it, the stuff that you actually want to change. So every time you ask it to do something, it's going to send the code, but also the prompt docs and the system prompt, and also all of the documentation for the different MCP servers. So you can see that it's got a lot of stuff that it needs to ingest. And then when it sends the response back, it sends the stuff that you're intended to read as a human, but it also includes JSON that is intended for agents within the AI clients to execute. So basically, the JSON is used by the agent to go and actually execute the tool according to the spec. So you only see a small amount of actually what's returned by the AI.